Hello, I'm Dror Feitelson, and I'm going to present our research on how using and naming intermediate variables affects code comprehension. Intermediate variables appear when we take a compound expression and break it into sub-expressions. For example, we can calculate the Euclidean distance between two points using a compound expression, or else we can first calculate the horizontal distance, then the vertical distance, and use these two in the final equation in order to calculate the Euclidean distance. And the question is, which is better? This also comes up in refactoring. The change from using a compound expression into sub-expressions with intermediate variables is called an extract variable refactoring, also called an edge-explaining variable. The other direction also exists. This is called an inline variable refactoring. The fact that both exist indicates that guidance is needed about when to use each one. To conduct such an experiment, we first need to select the code. We decided to use basic mathematical functions in order to avoid domain knowledge issues. We chose functions from different subdomains, such as geometry and probability. We validated the function we chose during the pilot study in order to identify codes that are too easy or too hard, and in the end, we selected 6 out of 10 candidate functions. Importantly, each of these functions has 3 versions. One using the compound expression, a second using intermediate variables but with meaningless names, and finally a third with intermediate variables with meaningful names. The fact that we have the middle version enables us to distinguish between effects due to structure and effects due to naming. Here's an example. These functions calculate the variance of an array of numbers. The first one uses one compound expression. In the second, we extract the length of the array and the average of the array into intermediate variables, but we give them meaningless names, temp1 and temp2. Finally, in the third version, we call the length of the array n and the average mean, and use that in order to calculate the variance. The experimental task given to the subjects was to name the functions. This obviously requires understanding what a function does, but is hard to check. An alternative we also considered is to give subjects a list of names as candidates. This is easy to check, but it has a disadvantage of guiding the subjects toward what the function actually does, and it could cause a bias. Therefore, we decided not to use this approach. The metrics we used are the correctness in the names and the time to answer. The experiment was executed using an online platform, the Lime Survey platform. Each of the subjects saw all 6 codes in a random order, and obviously each subject saw only one version of each function. The participants were recruited both from the university and from using work connections. 36 were excluded because they did not report knowledge of Python, which is the language we used. Of the rest, less than half were undergraduate students, and more than half, nearly 60%, had at least 3 years of programming experience. As I mentioned previously, the major difficulty in the experiment is judging whether names are correct. To do so, we devised the following protocol. One of us created a key of what constitutes good names, and then all 3 authors independently applied the key to judge the names. We then met in order to discuss cases of disagreement. There were only 38 such cases out of a total of 601 names for all of the all of the functions and all of the subjects. Here are examples for how we decided whether names were good enough. For example, in the function calculating the arithmetic sum of an array of numbers, we required the words arithmetic and sum or equivalence, but we did not require a series or array. For example, we did accept a name such as some linear array. In a function calculating the bubble sort, using bubble sort to sort an array, we required sort, but we did not insist on identifying correctly the algorithm that was being used. This graph shows the correctness results. As one can see, in 3 of the functions, the sorting, identifying prime numbers, and calculating the variance, there are very small differences between the 3 versions in terms of correctness. In 2 additional functions, arithmetic sum and identifying parallel lines, it appears that the breaking intermediate compound expressions and using intermediate variables with meaningless names actually reduce the performance. And only in 1 function, identifying right angle triangle, we see a progression. creating intermediate variables made one improvement, and giving them meaningful names gave an even better improvement in identifying the functionality correctly. These graphs show the distribution of time to find an answer. These are CDFs. The red line represents the original version with a compound expression, and the blue line is the third version with meaningful names. As we can see in 3 of the functions, calculating variance, identifying parallel lines, and identifying the right angle triangle, the distributions are distinct from each other, and subjects which were given the version with intermediate variables with meaningful names worked faster. In the 3 other functions, there was no significant difference. Interestingly, the difference is also dependent on the absolute hardness. For example, functions that took more time to understand, the difference in when given intermediate variables with meaningful names was also bigger. Likewise, the functions where initially the percentage of correct answers was low, again, the improvement was bigger. So harder functions improve more. If we put all of these together, we can conclude that there are several different cases. On one hand, we make a distinction that easy cases, it does not make much of a difference which version of the code you use. On the other hand, in the harder cases, when you break the component expressions and create intermediate variables with meaningless names, performance could be worse. But if you give them meaningful names, performance will be better. We therefore conclude that in general, intermediate variables can be recommended, but one has to make sure that you give them meaningful names. Thank you.
All right. Hello, everyone, and welcome to the session on naming. My name is Venera Noudova from Washington State University, and I will be the session chair. So thanks, Dror, for the presentation. Very interesting work, super interesting. Let's dive into the questions. So if you have questions, please enter those in the chat. So my first question would be, so one of the main conclusions was that it would make sense to use intermediate variables for harder cases. And I was wondering if you can give us more insight into what harder cases mean here from the samples that you used for the study.
So in our in the functions we use, it's actually more an issue for the semantics. We didn't measure, and it's not related to the usual complexity measures like MCC or something like that. It's more the conceptual complexity in a sense, because the functions that came out hardest were 2 functions that come from the area of geometry. And I think that the problem is that most people don't remember those geometry so well. So the function was to identify a right angle triangle, for example. So, and the way we did it was we checked each possible combination of 3 sides being a Pythagorean triplet. And so people probably try to figure out what's going on there, and that's what's caused them trouble, and they try to remember what this means. And the other one
domain knowledge.
Identifying parallel lines, so then you need to calculate the slopes of the lines by the differences of x divided by y. So that was what made it hard. So it's more conceptual difficulty than a code complexity.
Okay, sounds good. Thank you. There is a question from Fabio in the chat asking, what do you think about A.B.C.D?
That could definitely be a problem, and we didn't study that explicitly, but it's a big issue of whether you should really string those function calls one to another, which is sort of in OP. It's sort of a common idiom to do that. We didn't study it explicitly. I personally don't really like it too much because I get confused and I don't remember what's going on and who. But if the function names are very good, it could be useful, because if the function names are so good that you're actually reading a sentence, then it could be beneficial. If they are not, then you should probably break it up.
All right. So I don't think we have.
Okay. Venera just disappeared on me. I don't think intermediate variables should be created just to be returned. There's a question on that. I think it's more